Hey, thanks for being here. My name is Tim. I work for Confluent. I used to work for Confluent years ago, and now I do again. So I guess I just couldn't stay away. I work with the developer relations team there, and our job is to do things like this, and to make videos, and to make courses, and just to kind of make it easier to learn how to do streaming. And since I spend a lot of time in that space, I've been thinking about how the way we're building systems is changing. And it's hard to say, you know, I'm tempted to say that's changing because of Kafka. It's complicated, right? You know, Kafka comes into existence because we need it for certain things, and then it gets adopted and it helps change things. It's all kind of part of the same thing happening. If you're going to be at Java Zone this week, I have a talk on Thursday. I think it's the last talk of the day. I don't know why they do that to me. Like, I thought we were friends. But late in the day on Thursday, that's kind of a historical perspective on why this is happening. But I'll give you a little mini version of that history just to set the stage for what I'm thinking about. Now, there was a time recently that was simpler, where we built what we called monoliths. At least we started calling them monoliths at some point when we wanted to make them seem like villains. But you know, you had a database. That database had a snapshot of everything in the world that was true. And then you wrote a program that made changes to that database or read that database. Now, sometimes representing the state of the world in a database is hard, right? It's not like it was ever easy. Sometimes user interfaces were hard. Business rules were hard, right? It wasn't that life was all a piece of cake back then, but it was something that we kind of knew how to do. And there was a few decades of history before that where it was sort of like a known way to build an application. And some of us even got good at it. And because of the way databases worked, we would do a thing, and to get insight into what was going on, we would extract changes from the database every day or every half a day or something, kind of squish them around to another form, and put them in a separate database, the data warehouse, so we could make dashboards or reports against that. And that data warehouse drew in lots of different sources and optimized the schemas, pre-computed all this. It was a wonderful world. We had these great data warehouses that we built. And that all worked. Monoliths and legacy data warehouses kind of worked even after the internet happened, until mobile devices happened. Kind of in the late 2000s, when smartphones really started to hit, that architecture, the monoliths, legacy data warehouse, could not survive what happened with data when the internet penetrated through into smartphones. This revolution kicked off what we remember as the era of big data. Things like Hadoop came into being that gave rise to 100 other things. And it broke the old way, right? And so now what we started breaking the monolith into pieces. And in the early days of microservices, like, I don't know, Java Zone, I think 2010 was the first Java Zone I spoke at, 2010, 2011. I'm sure there were talks on microservices back then, and most people were not having a good time with microservices. It just wasn't a good thing. Eventually, we started to figure out, okay, it's better for microservices to exchange events. And so now we've got all these pipes running around Kafka topics. And this is kind of the way that we do it, all right? This gives us this ability to process data in real time, to exchange data between services. And that's a pretty good thing. Now, the data lake, which is kind of the descendant of Hadoop, we still have those. Okay, and that's still a little weird, but this became standard. And really where we are now is that logs, the Kafka topics, which are not queues, but they're logs. Logs are now the fundamental data abstraction that governs the way we build systems. That's sort of the substrate that we build everything on top of now. And they are really a better way to get services talking to each other. Most people find that that's better than synchronous API calls between services, or the early ways of microservice integration. Logs are easier to extend, easier to reason about, but there's one thing: they are hard to query. And so that's really what this talk is about. How do you ask questions of what's in a log? Now, fundamentally, you can't, right? All you can do is scan the log. The log itself is not queryable. But this is a thing we need, and there are all these solutions kind of floating around out there that all have good things and bad things about them, and that's what the talk is about. Now, you could say, a different way to say this is we're kind of struggling with how to combine databases and streams. Databases do not go away in this new world of Kafka. I don't think that's anybody's experience. Years ago, I used to have people ask me a lot if Kafka is a database. I don't know if that's like they're trying to start a fight, or they're really curious, or wonder what I thought. It's a weird question. It's not, I don't think. There's lots of databases. We have all kinds of databases in the world. And I think this, how to query a stream, really represents our collective struggle to figure out how databases and streams work together. Now, when I say database, most of us in this room are thinking of a transactional database, right? If I say that, you probably think of Postgres or something like it. That'd be an interesting Slido quiz to do sometime, a word association. When I say database, you think, do a word cloud, and probably Postgres would be real big. And those kinds of databases that we think of are optimized for transactions. That's when something changes in the world and you want to remember that change in your database. But there's also what now often happens in the data lake, what used to happen in what was called the data warehouse, or you might do it in a cloud data warehouse. We're going to look at those. So there's reflecting transactions, remembering what has changed in the world, and then there's trying to understand what has happened. So you could say the first one is OLTP, the second one is OLAP. And those two ways of being a database, those two ways of thinking about querying, totally show up. That paradigm absolutely carries over into the streaming world. So as we look at these different ways of querying a stream, and they are, lest we bury the lead, they are these things. As we look at these, you're going to see most of them kind of fall down on one side of that divide or another. They're vaguely transactional or vaguely analytical. Some are both, and we'll cover that. And I'll give you a little bit more about what I mean by transactional and analytical in the sense of streaming. Sometimes when I give a talk, I start by asking, what are you hoping to learn? I kind of forgot that. I just got excited. Let's blame the jet lag. But before we dive in, and now you kind of know what's going on here, is there any sort of question anybody came with or like curiosity about this topic? You mean Microsoft's hosted Kafka? Yeah. Oh, yes. What is the question?
Well, I am .NET developer, so I'm trying.
When the corporate security decides it's going to pop stuff up, and we're back. We're back. Sorry, .NET developer, Azure Kafka.
So I want to learn how to integrate .NET and Kafka.
Ah, okay. That's a little bit. I probably won't directly cover anything .NET-y tonight. We're going to stick in this general category of the ways of asking questions about streams. The good news is most of these can apply to .NET.
Okay, one more thing. What about architectural concept in event-driven architecture?
Yeah, this is, I want you to think of this as like a subtopic under that. It's not broadly event-driven architecture. I definitely have some YouTube links. Let's talk afterward, and I'll send you some, I think, helpful links on that topic. Yeah.
Are we using Oracle database as a cache for the UI?
Okay.
To stream data from Kafka down to the Oracle database. Is it possible to use some kind of streaming SQL instead? And what's the pros and cons of doing that?
Yes. Let's revisit that at the end because there are a few things I'm talking about that are potential substitutes. It's not obvious ahead of time like which one's right. But there are a few tools here that might even be better. Like Kafka Streams comes to mind off the top of my head, but it sort of depends what's going on. You're in the right place. Yes.
This actually just came up this week for one of our teams. They have a lot of data coming from Kafka, and they build APIs and front ends, and they sort of are asking how should we pick individual events and show it to the customer?
Yes.
To see it. So for example, your data should only be shown to you, but from this Kafka stream. And Kafka topic. And we think it should be Kafka streams, but we also confused, could it be KSQL? Could it be Flink? Could it be something else?
Yeah, okay. I'm going to answer that question. And we're in this time in life as a community where it's just such a dang obvious thing to want to do. And you have to go, well, which one am I? It's weird, right, that we're there. We're here. We'll sort of end with this idea, but I'll suggest it now, because this is new territory that we're collectively exploring, and we're in this period where there are all these weird options, but it's just such a darn obvious thing to do. You got stuff, you need to ask about stuff. And sure, you need RBAC and multi-tenancy and rights and all those kinds of normal things, but yes, I mean, it could very well be Kafka Streams, could be KSQL. It can't be Flink, but we'll get there. Don't worry. I mean, Flink is probably a part of the world here, but it's got a unique place in this.
In the simplest case scenario, you could build a consumer and just writes to a database, and then you query that database.
Yes, or you could do that with Kafka Connect, and that is our first option. So this is Kafka Connect in the Italian Renaissance. This is how it worked, what it looked like back then. No, I asked GenAI to make pictures of these concepts in the style of an Italian Renaissance artist named Caravaggio. If you're wondering why they all look funny, I thought it would be cute. Anyway, Connect and a relational database. This is a big giant Connect cluster, and I guess these are Connect workers or maybe database tables down here, whatever you would like to think of them as. Connect, if you don't know, it's a part of Apache Kafka. If you use a managed Kafka like Confluent Cloud, it exists in a managed form in there. But you've got a Kafka cluster, and now you have separately a few of these Connect worker nodes. It's its own little cluster that is attached to the Kafka cluster, but isn't Kafka itself precisely. But it's a part of the open source Apache Kafka project. And what you can do is you can install these pluggable connectors in there. There's a giant ecosystem of hundreds of them. And you describe with a little configuration file what you want the connector to do. And so now it's like this declarative piece of infrastructure that will, in our case, we're thinking of sync connectors. It's going to read from a Kafka topic and write to a database. So you could write a consumer to do that yourself. I will say that is, as Admiral Akbar would say, a trap. It's harder than it sounds. I mean, obviously, the first pass at that you can code in 20 minutes if you're familiar with all the pieces. But there's a bunch of details that get in the way, and Connect is battle tested for a decade to handle those details. So you probably want to use Connect and a connector. But yeah, basically, it's this tool that's going to read from the topic, write to the database. Simple as that. And then you query the dang database. What's good about this? You know how, right? You have a database that you like and you know how to use. What if you have a few different fields that you need to do queries by? Well, make indexes for them. Databases are good at that. Like, all this stuff just works. So it's nice. It's typically, we don't use this for giant data, but that's a moving target, right? Like things like Postgres are bigger and bigger at larger table sizes. So whatever small means, it means, does it fit in a table on a server that you're comfortable provisioning? You just kind of have to keep an eye on the ball there scale-wise. Otherwise, very simple. And this is on the transactional side of the fence. So typically, you're thinking of a key lookup. And that's a lot of what this transactional stream querying is there's probably an ID, a UUID, the key of the Kafka topic, and we want to look up by that thing and get the record out. So when I say transactional, I mean not in the sense of writing or anything like that, but looking up by a key, which is the kind of read that dominates the world in transactional databases as opposed to analytical databases. And again, this is a super familiar tool set. If you don't know Kafka Connect, okay, you have to learn that. It's not that bad, and this gets the job done. This is a great tool to have. Again, I'll point out, It's interesting that we're at this point in life where we've decided to keep data in these Kafka topics in logs. And, you know, I'm kind of selling this as familiar and easy, and it is. But I still have to like make this extra thing to get this job done, right? That should be, if you've been around for a while, that should be a smell that there are parts of this platform that aren't done yet, which I mean is a good thing. You know, it's kind of fun to be able to be alive and around at a time when this stuff's being built out. All right, that's enough of Connect, simple concept. That's the first way to do it. Now, Kafka Streams, this, oh, sorry.
How can you handle schema evolution? Is there something like that?
Question is, how can we handle schema evolution? I don't think we've ever been able to handle schema evolution, I mean, personally, for anything. But, you know, it still happens, and it always kind of sucks. But the answer in the Kafka space is a component called the schema registry that allows you to define schema compatibility rules, and then which schema compatibility rules which then imply the order in which you're going to roll out schema changes. Do they happen producer first or consumer first? And so, again, if you'll let me like literally wave my hands about that, use the schema registry, it's doable. The schema registry is a tool to help document schemas, have an official place where they live, and keep you from doing things that are going to cause breaking changes. It doesn't make, you don't want to go into this thinking, oh good, I have this thing that's going to make schema evolution easy, because there isn't anything that makes it easy. This is just something that makes it possible.
Yeah. That's on the Kafka side, but when it comes to syncing to database.
Yeah, that's however, like I said, however it is you do schema evolution, there isn't anything on the Kafka side that will go over and say, oh, let me go do the alter table statements. So you'll have some kind of tooling that does that, and you got to manage that.
That makes it difficult for any database to rejoice for Kafka syncing, I believe.
Well, yeah, I mean, I started with, it's always hard. It doesn't make it impossible. I mean, this is still, you can absolutely still evolve schemas with Connect and a relational database. Whether it works for you is another matter. And if it doesn't, then we can consider Kafka Streams. Now, last talk had an excellent walkthrough of some Kafka Streams code that was mercifully simple. I love that topology. But let's talk about this. Now, Kafka Streams will work on the transactional side and the analytical side of the equation. Let me talk about both. So, thinking transactionally, that is, I want to enable the key lookup thing. I have a topic full of things, and I want to go get one out of it. So a Kafka Streams will make a Kafka Streams topology that will ingest directly from a topic and create a thing called a K-table. Now, K-table you can think of as an in-memory hash table representation of a topic. So looking in that topic, you have Kafka events. They're a key and a value. You read them in, put them in the hash table with the key as the key and the value as the value. So that fits in memory. It's also replicated on disk and in various ways. And if you don't like the in-memory-ness of it, there are ways to scale that across several nodes in the consumer group. So it is scalable. It is in memory. I even have a bullet that says that, so it must be true. And there is a separate API called interactive queries. It's not separate. It's an API that's a part of Kafka Streams that you use to do the reading out of the K-table. And what that lets you do is effectively a key lookup of what's in that K-table. And this works, again, battle tested. Kafka Streams just turned 7. There are books, sample code, people who have done it, people who know how to do it. It's a pretty time-tested thing. The actual code for creating a K-table is 2 lines, super easy. I will say interactive queries does feel as an API like it wants to make sure your heart is in it. You know, there's a lot of stuff you have to do that doesn't feel entirely wrapped, because again, the obviousness of the problem feels like this should be a thing I declare somewhere in a line of config or a checkbox in a cloud UI. It just happens, and it's not there yet. Okay, on the analytical side of things, Kafka Streams, again, full-featured stream processing API, any kind of arbitrary stream processing computation you want to do. And you can, for example, and we just saw this, ingest a stream, and you had like some stateless filtering, and you produced a new stream. So you can emit a new stream from Kafka Streams. We don't care about that right now. What we care about is asking questions. So again, if I am, say, going to ingest and then group by some field and run an aggregation function over some other metric in the message, and that's going to create now a table with the group field as the key and the aggregate result as the value, I can look things up in that K table now with interactive queries like I did before. So this is a nice toolbox. And if you're using a tool in your toolbox, if you are a Java shop and you're using Kafka heavily, it's probably a good idea to know some Kafka Streams, right? You might need to pull this out and use it every once in a while. Every different question you want to ask of the stream is going to require that you write your own, write a separate topology. So you're effectively writing a separate Java application for every kind of question you'd want to ask. It begins to feel, in that case, like, shouldn't I be using SQL for this? You know, it might start to feel like a lot of work, but a lot of shops use this, very common solution, and absolutely not at all a bad way of asking transactional or analytical questions of a stream. Every single one of these has trade-offs. So if it seems like I'm not really selling any one of them, I'm really not, because they're all just tools that we have to be aware of so you can pick what works. Some code for a word count. So this is tokenizing and grouping and aggregating. You know, not intended to, the font is small on purpose. I really just want you to have a sense of like, okay, how much code does it take to do that? All right, after Kafka Streams, which is a thing you got to know about, we have the various streaming sequels. And these are, every time I talk about these, I start to feel like I am repeating myself. And if I do, so we'll talk about Materialize, Delta Stream, Rising Wave, and KSQL DB, and if it sounds like they're all very similar, I just want you to know that's not my fault. They actually are very similar. They're as you dig in, like if somebody gave sort of an hour-long talk on each one of these, there are interesting differences. A couple of friends of mine, Ralph de Buesman and Hubert Dulay, just published a book called Streaming Databases, and they've got chapters on each one of these that do get into some of the interesting differences. But at the survey level, they're all very similar. Also, we'll see if Flink SQL belongs in this list. But let's just go through these in a summary fashion. So Materialize is a streaming SQL. I call it that because it wants to ingest from streaming data sources, and the way that you define queries is using SQL. And it's really billing itself as a replacement data warehouse. So if the old style of data warehouse is old and busted and dead, and all of your data is in Kafka or some other streaming source, well, bring it into Materialize, write SQL, and you'll have a better life. And it's able to ingest from non-streaming sources as well, like Postgres. So the central abstraction in Materialize is, perhaps unsurprisingly, the materialized view, and that's where you get to be queryable. We're not just writing SQL that defines transformations of one streaming source to create another streaming source or streaming sink, but you're really creating tables. And those are queryable, persistent things. Postgres wire compatible, which I think in the future, everything that looks like a database will be Postgres wire compatible. I personally don't care for the Postgres CLI to spread itself too much, but otherwise, I think this is a good trend, Postgres wire compatibility. And Materialize very much positions itself as I said, a data warehouse. It is trying to be an analytics solution. Okay, now there's Delta Stream. Delta Stream is a little more flexible. It definitely does analytics things, but it's not trying to pigeonhole itself there. It is a cloud-native streaming SQL. The founder of the company is one of the original developers of KSQL. And really what he did is he said, okay, this is how this works, I see, but what if I was going to do this in a completely cloud-native way? And I wasn't necessarily beholden to Kafka, and I didn't need to make it so that you could download it and run it on your own. What if we just had the freedom to build this as a cloud-native thing? And that's what Delta Stream is. And as a cloud business for the size and scale and age of the company, pretty sophisticated. They've got a great serverless offering. They support bring your own cloud, which not everybody does. So, you know, that's pretty cool for them being a relatively new shop. Kafka and Kinesis ingest, and again, explicitly being on the transactional and analytical side of the fence. You could build streaming pipelines. You could build materialized views. They're comfortable as both really as a streaming database and streaming analytics. It's good at both of those things. But as a way to create a queryable table, whether you're doing key lookups or some kind of grouping and aggregation ahead of time, Delta Stream works. Okay, rising wave. Very interesting situation here. Again, in their own description of themselves, they're called a distributed SQL streaming database. There is an open source version that you can download and run. There's also a fully managed version that you can buy from the folks at Rising Wave Labs. And this is based on a rewrite of Flink. So if you were ever a Cassandra user or invested in that community at all, you may know there was Apache Cassandra, which was written in Java, and then there was a C++ clean room implementation called ScyllaDB. In the Hadoop days, there was Hadoop itself written in Java, and then there was MapR, again, a re-implementation in a non-memory managed language. Well, now we've got Flink and we've got Rising Wave. It seems like this happens, certainly Kafka and Red Panda and all these things. There's always a non-memory managed version of the successful Java thing. And often they capture use cases that are very sensitive to tail latency. So Java garbage collection can cause the 99th percentile latency to be a lot higher than the 95th percentile latency in some cases, and these C++ or Rust versions do better there. So there you go. But not only is it just a re-implementation in C++, but it adds persistent views. Now we're going to talk about Flink in a minute, spoiling that right now by saying that Flink is itself not queryable. So that's why Flink gets a question mark even being in this talk. It's just a big enough technology that it would sort of seem weird if I didn't address it. But Rising Wave is like Flink, but with queries. And again, as all databases will be in the future, PostgreSQL compatible. All right, KSQL DB is a product offered by Confluent. It's available in Confluent Cloud, also available for download and free use under Confluent's community license, which is almost but not quite completely like an open source license with the whole, how everybody's sort of doing that these days. That's KSQL DB. Describes itself as a streaming database, and like K-tables in Kafka Streams, it presents this table abstraction. And if you don't know about KSQL DB, it is actually implemented in Kafka Streams. So you can kind of think of it as a SQL parser that builds your Kafka Streams topology for you. I said before, if you got into the business of writing a lot of complex topologies for analytic queries on topics, and you were doing that in Kafka Streams, after a little bit it might start to feel like, couldn't I just use SQL for this? That's exactly what KSQL DB was designed for. So yes, you can. If you'd rather describe those in SQL than write a bunch of Java code, you can do that. And in trying to, KSQL DB was also to a large extent an attempt to rethink a database in the context of streaming. And as a result, the folks behind it, they realized there are certain kinds of queries you'd want to do on a stream where you just want the results to come to you. You want to issue the read and you want results to stream into the application, okay? And that's called a push query because the server is pushing to you. There's also pull queries where if I've created a table and I want to do a read of one key from that table, that's a pull query. I just read from that one key, and both of those are supported. Already said that. So, the squirrel. Flink. That's the Flink logo. It's a squirrel. Not that particular squirrel, but just a squirrel. One might ask, why not? Well, again, increasingly, Flink is an essential technology for stream processing, okay? It seems to be, of the various ways of doing compute over Kafka topics, it seems as if it is achieving a status of having won, in some sense. And that's a little bit of a silly thing to say, because it's not like Kafka Streams is going away or is an old-fashioned thing, or like any of these is necessarily bad, but Flink is becoming a standard way of doing stream processing. So it's an essential technology. It's likely to appear alongside any of these things that we see here, and it does perform stateful processing, and it maintains state internally, but that state is not available for you. Flink's view of the world is there are sources, there's stuff I do with the messages, and then I sync it to somewhere else. So as far as Flink is concerned, oh, you want to query this? Well, hey, I can sync to a database, let me do that. Flink would say, just put your Postgres there, define the job, and I'll write the stuff into the table, and it'll be queryable. So Flink doesn't let you query it by itself. That said, again, it I think will tend to find its way into a lot of these systems. Bookmark that, and when we come to Pinot at the end, I'll talk about Flink again. It's just likely to be a tool that shows up alongside you and what you're doing. Okay, where we're going to go next is cloud data warehouses. It's a great thing about Gen AI. Like, I want you to show a library with books on the wall, but in the clouds, in the style of Caravaggio. It's like, okay, we'll do that. You can't see anybody's hands there, so you don't get that. By the way, speaking of hands, has anyone seen it yet? Once you see it, you can't unsee it. That hand, that guy's hand. Something is very wrong. It looks like it really hurt. Yeah, okay, what do we have? We got BigQuery, we got Redshift, Snowflake, Azure Synapse. So what we know about the cloud data warehouses, first of all, is that they are blue. That was an interesting discovery of mine. I'd never actually collected all the logos and put them in one place. Like, okay, they're all blue. I don't know why. But these are, of course, the cloud-based survivor of the legacy data warehouse. All right, they are all able to ingest from batch and streaming sources. I think they're biased towards batch data and structured data. Okay, explicitly structured data. What do you do in a cloud data warehouse? You create a table and you put stuff into the table. So you are defining the schema of the thing, just like the legacy data warehouse of old. So it's willing to take the position that you should have a schema. And that's not been everybody's opinion in the last 15 years. So anyway, those are the cloud data warehouses. They are, the survivor states of our former relational database-based data warehouses. How about then the data lakes? What is the difference between a data lake and a cloud data warehouse? Well, architecturally, you have stuff, right? You got relational databases, you dump it in there, maybe there's flat files. I don't know what kind of data sources you have. It puts them into the data lake, or it gets the hose again. And Kafka, certainly. I can take Kafka topics, and one of the ways I might want to do analytics on a Kafka topic is simply to Kafka connect it into the data lake, dump it into Parquet files in S3 or something like that, and that's my data lake. Now, the data lake is the descendant of Hadoop. All right, I want to say that when Hadoop really took shape in the late 2000s, the whole idea was let's not worry about all that schema stuff, because we were moving away. Hadoop is saying data warehouses, old thing of the past. Everybody's always worried about schema. Schema migration sucks, right? Let's just not do it. Let's just extract stuff, put it in the data lake, and then when we have to read it, we'll worry about what the schema is. And so there was this revolution in military affairs. Instead of ETL, it would be ELT. And people who do what I do are saying this is going to change the world. Let's do it. Okay, so it started as HDFS. Really, it's S3 or whatever, cloud blob store of your choice. And this ETL versus ELT battle, again, golly, if you were paying attention and around in, say, 2010, and there were all these new databases being released one every other week that didn't use SQL or tables or anything like that, because we just don't need those things anymore. We have new kinds of data, and we're just going to get away from SQL. They tended to sprout a sequel about 2 or 3 years later. Okay, it's like being a teenager and leaving home and saying, "Dad, you suck. I don't like your politics, and your car is stupid." And then a few years later, you're like, "Well, yeah, you don't entirely suck. You might be smart about some things." And this same sort of developmental process happened, and I would contend is currently happening with data lakes. So the open table format wars, which seem to have been mostly won by Iceberg. This was a fight between two Apache projects, Iceberg and Hootie, and a commercial product called Delta Lake, made by, thank you, Databricks. See, get to a certain age, these things just go away. Iceberg seems to have come out on top in that battle, which is an admission by this community that we actually do need schema. And maybe it needs to operate in a slightly different way, but this is a way of imposing. It is a new form of data catalog. And I'll make an opinionated statement. I could be wrong. I think Iceberg has won the open table format war, and we are in for, more generally speaking, another catalog war about how our streaming and batch data is going to be described. I don't know that Iceberg is a solution for that, but I think the next few years we're going to see a war, a struggle for control over the catalog. And I'm kind of looking forward to that. Confluent has a new thing, which is an announcement. That's not true. There's some people using this in early access. It does exist. That's not fair. It's not a generally available thing, but it's called Tableflow, which is basically a way of taking what's in a Kafka topic and representing it as an Iceberg table. So that's not Kafka Connect consuming from the topic, and a way of representing what's in a Kafka topic in an Iceberg table that's a little more subtle than consuming and rewriting. It's like the same storage. It's Iceberg and it's topic. It's kind of a cool thing. It's, again, an observation, not a Confluent commercial, but an observation that people in the world are thinking about how do tables and streams relate. And this now also explicitly connecting a streaming platform to things that live on the analytics side of the world in data lakes. So this is either a blurring of those categories, or a wrong idea that won't work out, or a very interesting development that is showing the kind of the way territory is being explored right now. So yeah, this whole thing about trying to get rid of tables, trying to get rid of schema, never works. Never works. It is hard to kick against the goads. So let's just do it. All right, yeah, anyway, data lakes tend to be characterized by radically decoupled storage and compute. So I've got some kind of compute cluster over here and S3, blob store over there. We talked about the struggle with structure. Generally, these are not super high performance things, so you wouldn't use these for user-facing queries. These are for things like dashboards that are slower, and they're getting better at streaming, but that has never been their strong suit. So kind of a newcomer to the whole space, and the last technology we'll look at, is the real-time analytics databases. So there are a few of these. This guy is holding a glass of a light-colored wine, which must mean he is an Apache Pinot user. There's also Druid, there's ClickHouse. There was one called Rockset that was recently acquired by OpenAI and is being absorbed and will never be seen or heard from again outside of OpenAI. So there's a small number of these players. And what they're basically designed for is analytical queries, okay, so scanning, grouping, aggregating, filtering, that kind of stuff. Not key lookups, not retrieving whole records, but filtering and aggregating. When those results are going to be presented in a user interface, not a dashboard. So user-facing analytics. So high concurrency, maybe thousands, tens of thousands of queries per second at scale, and very low latency, like under 100 milliseconds for an analytical query, which is totally different than all the analytic technologies that come before it. And they're built to ingest from Kafka. They're like slurp data in from topics and make queries happen real fast. And certainly in the case of Pinot grew up alongside Kafka at LinkedIn, so it has a very close integration. And yeah, there's just tables in SQL. There's nothing to say about them as databases other than their interesting non-functional requirements and their kind of new entry as yet another way of querying a stream. Sometimes I've heard Pinot described as queryable Kafka. Now it's queryable in the analytical sense, but it's all designed to be instant and real time in ways that say your data lake never was and never will be. So if this is a thing you need, it's an interesting little piece of technology. All right, wrapping up. We're really talking about how to select technology here. This is a problem we face all the time. You have a problem to solve. There are 5 different ways to do it. Which one do you pick? We've seen there's lots of options. I've tried to be as real as I can about the benefits and the trade-offs of each one. But what do you look for? Well, sometimes you do look for what's familiar and easy for you as a team. And that's always relative to you as a team. That's contextual, right? Go with what you know. That's not bad to do that if it works. Sometimes performance matters, and you really do need to do a performance bake-off because you are trying to trim milliseconds or tens of milliseconds. It doesn't always, but when it does, that's important. Often, I think community matters when it's a new and untested space, and a lot of things in this space are kind of like that. Who else is using it? How big's the Slack organization? Is it growing? Will I be able to find people who know things? Are there good tutorials? Is there sample code? What is all that stuff? Are there meetups? What's all that stuff look like? But big picture, what I see happening here is exploration of unknown territory. I started by saying we used to know how to do it. We made a monolith, and life was not easy, but at least it was understandable. And now we're in this different world where we're building estates of event-driven microservices that are exchanging messages with each other through Kafka and having to solve problems in very different ways. Now, when client-server was a new idea in the 80s and 90s, in the early 90s, there was this explosion of weird kinds of databases and frameworks and ways to make UIs and all these things that are museum pieces now, if that, footnotes on a Wikipedia page. They just didn't make it. Some of them did make it for a long time. But we're there. So at the top is the code that you write that actually does something useful for somebody. It serves your user, it adds value to somebody. At the bottom is the new universal data substrate. It's like this new file system for events, Kafka. It's everywhere. Great. Well, in between, there's a lot of infrastructure that has to exist. We're often tempted to go build it. This talk has been about various pieces of infrastructure that fit in there, in this area we're exploring. Some of them that are on a slide now maybe won't be in a couple years. Some things aren't even a slide in this talk yet, and if I'm still giving it in 2 years, they will be. And frankly, I think there are still parts of the map here that don't even fit into how to query a stream necessarily. They're just new pieces of infrastructure that we have yet to create and get nailed down. I feel like we've got another 5 or 10 years to really get to a stable place with the new event-driven world. I think there's a lot of fun exploration, fun creation, experimentation, which is sometimes fun, sometimes massive pain in the butt, that we get to do as application developers. And that's, I think, where we are. It's a kind of cool time to be alive. So with that, if you want to know more about Kafka and Flink, go there. And that's me. If you send me a connect request, say you were at the Oslo Kafka meetup if we didn't meet personally, and I would love to be connected. Thanks.